Okay.
Okay, sir.
There is a problem later again, you will forget the concepts here. So whenever I'm teaching, immediately you have to practice all that questions. Okay. And I'll try to send some assignments also. Right, ma'am. So in last class, we discussed about the oxidation number, what is the oxidizing agent, what is the reducing agent, okay, and what is the oxidation and what is the reduction reaction. Okay. Now, so today we are going to discuss about the balancing of the equations. Okay. So what is the main important concept we are going to be discussing here? So we are going to discuss balancing of equations. Balancing of equations. Okay. So here, balancing of the equations, we can do two methods. So one is hit and trial method. So one is here, hit and trial method. So what is mean the hit and trial method means here? Generally, we are not using that one here. Okay, the first one is we can use as here, hit and trial method. One is hit and trial method. Second one is here, oxidation number method. Oxidation number method. Okay. So third one is ion electron method. Ion electron method. Okay. So in these three, so based on which one they're asking the questions in the examination part means here, they're asking the questions based on ion electron method. Okay. So before going to the balancing of equation, first what we have to know means here, first we have to know molecular formulas of the compound. Okay, so what we have to know here? First, we have to know the molecular formulas of the compound. Okay, so now only just I had gone through. Okay, so I had gone through previous mains level questions. In that one questions, how they ask the questions now? They had given in sentence formation. They had given in a sentence formation. But if they had given sentence formation means how we can balance the equation? First, we have to know how to write the molecular formula of the compound only now. If you know the molecular formula of the compound, then only it is possible to find out the, then only it is possible to balance the equation. Otherwise, it is not possible. Now you got the clarity? Okay, so many questions are there. In statement formation, they had given, they didn't mention any molecular formula also. In a statement formation, they asked some questions here in previous years here. Okay, so first we have to know the molecular formula. If you know the molecular formula means what is the second step we have to know means here, we have to know how to write the ionic equations. All of you know the how to write the ionic equations now. For example, okay, if they had given us a KMNO4, first I'm taking as some example here. Okay, I'm taking as a example here. So for example, KMNO4 is the compound. KMNO4 is nothing but potassium permanganate. Okay, so KMNO4 is nothing but here potassium permanganate. When the KMNO4 is, it undergoes to the ionization. What are the ions it is forming, Sriyuta? Potassium permanganate is, it undergoes to the
It's
ionization.
K plus and MnO4 minus.
Very good, ma. K plus MnO4 minus. Okay, for example, aluminum hydroxide, it is there. AlOH taken 3 times. So what is the ionic equation of this one here? Al plus 3 plus 3OH minus. Al plus 3 plus 3OH minus. Okay, so this is the ionic equation. So if they had given any compound or any salt, first we have to know how to write the ionic equation. Okay, if you know the ionic equation only, then only it is possible to balance the equation. Otherwise, it is not possible. That's why we are calling as an ion electron method. In ion electron method, first they are giving as a compound. Compounds are writing as a, we are converting to the ionic equation. Okay, so that is the second step. After writing the ionic equation, so next step we have to find out the oxidation number of the each and every ion here. Okay, so we have to find out the oxidation number of the each and every atom in a given molecule. Okay, after finding of the oxidation, if you know the oxidation number means, based on that one, we can separate the which one is oxidation reaction and which one is reduction reaction. Okay, so which one is undergoes to, how we can identify whether the given ion is undergoes to the oxidation? How we can identify whether the given ion is undergoes to the reduction reaction? How we can identify, ma? Suyita, how we can identify whether the given ion is undergoes to the oxidation?
If it undergoes oxidation, then there is an increase in oxidation number.
Very good, Suyita. Okay, Samhita J. So how we can identify whether the given ion is undergoes to the reduction reaction? How we can
Sir,
identify?
if there is gaining of electrons or decrease in oxidation state.
Very good, ma. If the decreasing of the oxidation number means, based on that one, we can identify whether the given ion is it undergoes the oxidation or reduction. Gaining of increasing of the oxidation number means it undergoes the oxidation reaction. Decreasing of the oxidation number means it represents as a reduction reaction. After finding out the oxidation reduction reaction, both reactions we are writing as a separately. That is only we can call as a oxidation Hop reaction, and another one is we can call as a reduction Hop reaction. Okay, after separating of the oxidation Hop reaction and reduction Hop reaction, we have to balance the equation, and that is also based on the given reaction condition, because of some chemical reactions are they carried out in presence of acid, some chemical reactions are they carried out in presence of base. So whenever your reaction is balanced in acidic medium means we are following some set of rules. So whenever you're going to balance the equation in basic medium means we are following some set of rules here. Okay, so for example, if the given reaction is that, okay, for example, I'll give some example. Only one example I'm going to be explaining here. Okay, so what is the example means? For example, they are given as MnO4 minus ion is treated with the oxalate ion. Treated with oxalate ion. Oxalate molecular formula is C2O4 2 minus. Okay, in presence of acid, it is converted into Mn plus 2 plus it is converted into CO2. So this is the equation they had given. This is the equation they had given. Okay, right, ma. So how we are going to balance this equation, ma? How we are going to balance this equation? Is any idea? Now, first of all, what I am telling that already they had given us ionic equation. Already they had given us here ionic equation. Okay, so after giving the ionic equation, for next what we have to do, we have to find out the oxidation number of the each every element here. Okay, in this one, what is the oxidation state of the manganese? MnO4 minus
+7.
+7. Very good, Singita. Oxidation number of the manganese in MnO4 is +7. Okay, and what is the oxidation number of the carbon in oxalate ion? C2O4 2 minus. What is the oxidation number of the carbon in C2O4 2 minus?
So 3.
Very good, man. It is +3. So what is the oxidation number means here? It is +3. Okay. And what is the oxidation number of the carbon in CO2?
+4.
So which one here? +4 is the oxidation number. So what is the oxidation number here? +4 is the oxidation number. Okay. Now you can tell me that here. So already you find out the oxidation numbers of the each and every element. Okay. Now you have to find out the which element is it undergoes to the oxidation and which element is it undergoes to the reduction reaction. Is manganese, it undergoes the oxidation reaction or reduction reaction? From manganese to manganese, you have to check it out. So if you see MnO4 minus, manganese is having +7 oxidation state. Okay, in this one it is having +2 oxidation state. +7 to +2. Oxidation number is increases or decreases?
Decreases, so it's reduction.
Decreases. Hence the manganese is, it undergoes to the reduction reaction that I am going to represent with the R. Okay, now in oxalate, the carbon oxidation number is +3, it is there. +3 to in carbon dioxide, it is having +4. Oxidation number is increases. Oxidation number is increases means the given reaction is oxidation reaction or reduction reaction? Oxidation number is increases. Then the given reaction is oxidation reaction or reduction reaction?
Oxidation.
Oxidation, very good one. Increasing of oxidation number is called as a oxidation reaction. Now we find out the oxidation half reactions. Okay, oxidation half reaction also we find out, and reduction half reaction also we have to find out here. We find out. Okay, now after finding of that one, we are going to balance separately. First, I'm going to balance the reduction half reaction that I'm writing as a RHR. RHR is nothing but reduction half reaction. Sir, how we can balance the reduction half reaction means, let us see. What is the reduction half reaction is there? MnO4 minus gives rise to Mn+2. Point number 1. Other than oxygen and hydrogen atoms, what are the other elements are there that we have to balance? Okay, in the first condition, other than oxygen and hydrogen, what are the other elements are there that we have to balance? What are the other elements are there? Manganese. Okay, so both side, at reactant side, at product side, number of manganese atoms are same or different? It is there?
Same.
Same. Okay, so both side it is same. So number of manganese atoms are balanced. Next, what we have to balance?
Oxygen.
What we have to balance, ma? Oxygen we have to balance. Okay, so how we can balance the oxygen means wherever the deficiency it is there, that side, that many number of, how many oxygens are deficiency it is there, that many number of water molecules we have to add. For example, let us see, at left hand side, how many oxygen atoms are there?
4.
4. Right hand side?
0.
0. So to balance the number of oxygen atoms, we have to write the number of equal number of water molecules. How many oxygens are deficiency is there? That many number of water molecules we have to add. That means H2O. How many are there? 4 are there. Hence we can write as a 4H2O. Once you checked out number of oxygens are balanced or not? Right hand side and left hand side. Both side it is balanced only, na? Okay.
Yes, sir.
So next we have to, in the second step, we have to balance the number of hydrogens. How we can balance the number of hydrogens means wherever the deficiency is there. So that side, that many number of H plus ions we have to add, because of the reaction is carried out in presence of acid. If the reaction is carried out in presence of acid, means how many H plus ions are how many hydrogens are deficiency is there, that we are representing in the form of H plus ion. Now, right hand side total number of hydrogens is equal to
8.
8. So that means left hand side, how many hydrogens are deficiency is there? 8. The next step I'm writing as a MnO4 minus plus 8H plus gives rise to Mn+2 plus 4H2O plus 4H2O. Okay. Now, so if you see, so number of hydrogens, number of oxygen, number of manganese, everything is balanced now. Everything is balanced or not?
Yes, sir.
Then we have to do the charge balance. So what is the charge balance and how we can do means here, the number of electrons difference between two ions. Here you told that as a +5 and here it is +2 it is there. That means total number of electrons is equal to 5. The number of difference electrons is equal to 5. By gaining of the 5 electrons, +7 oxidation number is decreases to +2 oxidation number. Then it becomes as here +5 electrons. Okay, so sir, why we are adding as a left hand side means gaining of electrons can be represented with left hand side. Losing of electrons can be represented at right hand side. Now whole equation is balanced. Okay, and second half also we have to balance now. Only half reaction only we balance, and second half it is there. What is the second half here? Oxidation half reaction. Oxidation half reaction. Sir, how we can balance the oxidation half reaction means here, let us see ma. Here C2O4 2 minus gives rise to CO2. This is the equation they had given. First of all, what is the condition? Other than oxygen and hydrogen. Other than oxygen and hydrogen means what are the other elements are there? Carbon is there. These number of carbon atoms are balanced or unbalanced?
Unbalanced.
So how we can balance means by multiplying with the suitable number. Okay, so we can convert the one carbon into two carbon means by multiplying with the two only na. Okay, so if you multiply with 2, if you multiply with 2 means it is converted into 2 moles of the carbon dioxide. So number of carbon dioxide, number of carbons are balanced or no? Number of oxygens and number of carbons, once you check it out ma?
Yes, sir, they're balanced.
Is balanced. Is charge is balanced?
No, sir.
Here plus 3 it is there, here plus 4 it is there. Okay, it loses 1 electron. The total number of electron lost in a chemical reaction is in this one. How many electrons it is lost totally? You told that each carbon, sir, each carbon is increases plus 3 to plus 4. How many electron difference it is there? 1 electron difference. How many electron difference it is there? 1 electron. For 1 carbon, if it is 1 electron difference means how many carbon atoms are there?
2.
2. Hence 2 carbon atoms means we can write as a 2 electrons now. We can write as here 2 electron. So total number of electrons difference is equal to 2. The total number of electrons is equal to 2 ma here. Okay, now let us see how we can balance the whole equation means here. Sir, here we get as a 5 electrons. Here we got as a 2 electrons. Here we got as a 5 electrons. Here we got as a 2 electrons. Okay, so if you multiply with opposite number, one is the even number is there, another one is odd number it is there. So odd number we cannot convert it to the even number, and even number we can't convert into the odd number. Is any possibilities that to convert like that? Is any possibilities there, ma? No, ma, it is not possible to convert here. So that's why we have to multiply with opposite numbers. Whole equation we have to multiply with opposite numbers. So that means this equation, whole equation is multiplied with 2. If whole equation is multiplied with 2 means here it forms 2 moles of MnO4 minus plus 2H16H plus 10 electrons gives rise to 2 moles of Mn plus 2 plus 8 moles of H2O. Okay, now second equation. What are the second equation is there? That whole equation is multiplied with 5. The whole equation is multiply with 5. If you multiply with 5 means how many moles of the oxalate we are taking? 5 moles of the oxalate. C2O4 2 minus. Okay, it gives rise to 2 moles of the carbon dioxide plus, okay, sorry, 2 means 10 moles. 10 moles of the carbon dioxide and 5 2s are 10 electrons. So this is the completely balanced equation. Now, what are the things are there in opposite direction that you can cancel? Okay, here 10 electrons are there, here 10 electrons are there. That it is going to be cancelled here. Is anything is going to be cancelled in the given reaction? Sriyuta or Samhita? Is anything is going to be cancelled in a given equation?
No, sir.
No, ma. So then finally you can write as a equation. How we can write the equation means here 2 moles of MnO4 minus plus 5 moles of C2O4 2 minus plus 16H plus gives rise to 2 moles of Mn plus 2 plus 10 moles of the carbon dioxide plus 8H2O. So this is the balanced equation. That is here balanced equation. So based on this concept, they're asking the question. How many moles of the permanganate is required to balance? Okay, so oxalate ion. Clear?
Yes, sir.
Okay. So now you got the clarity, ma? All of you. So this is the method we are using in the balancing of the equation. So based on that one also we are having some questions. Okay, so based on this one also we are having some questions in the examination part. So first we have to know how to balance. Most of the questions they're asking in the acidic medium only. What are the questions they asked here? Most of the questions they asked based on here acidic medium only. So only one example is there they're asking here basic medium. Basic medium, after finding of the half reaction only, statement is going to be changed. Okay, in acidic medium, wherever the deficiency is there, that side we are adding the number of water molecules. But in basic medium, exactly opposite. Wherever the excess amount of oxygen is there, that many number of water molecules we are adding. Opposite side, double the number of OH minus ions we are adding. Okay, for that one, shall we practice one example, ma? Can I give one example? That is
Yes,
also
sir.
very, very, very important here. In basic medium, also very, very important. Okay, so one question is acidic medium, another question is here basic medium. Which you will get some clarity. Okay. Right. So another one is here balancing of the equation in basic medium. But we can't do this much of the lengthy process in examination. Fastly we have to do because of we have a less time now. Okay, so we have a very less time. Let us see, ma. First of all, P4 is converted into PH3 plus H2 PO2 minus. So this is the question they had given. The reaction is carried out in presence of basic medium. So what are the stoichiometric coefficients of the given reaction? What are the stoichiometric coefficients of the given reaction? Okay. So what are the stoichiometric coefficients means once we checked out, ma, how we can find out means balancing of equation. So what are the stoichiometric coefficients mean they're asking here? Balancing of the equation they're asking. This part, how many moles of the PH3 is going to be formed? How many moles of H2PO2 is going to be formed? How many moles of the P4 you are taking? Okay, so this we are going to be balanced in a basic medium. So to balance in basic medium also, first what are the first common steps are there means here? First we have to find out the oxidation number. So P4 oxidation number is 0 because of phosphorus can be exist in the form of P4. What is the elemental form of the phosphorus means P4. P4 can be phosphorus can be exist in the so P4 phosphorus can be exist in the P4 form. Hence the oxidation number of the P4 is equal to 0. In PH3, what is the oxidation number of the phosphorus means -3. In H2PO2, what is the oxidation number of the phosphorus, ma? Any one of you? What is the oxidation number of the phosphorus in H2PO2? Samhita? What is the oxidation number of the phosphorus in H2PO2?
Sir, +1.
Very good, ma. So it is here +1 is the oxidation. It is +1. Okay. Now, can you tell me which one is it undergoes to the reduction and which one is it undergoes to the oxidation number? Samhita?
So,
Samhita. Yeah, ma.
so with pH3 it undergoes reduction and with H2PO2 it undergoes oxidation.
Very good, ma. Okay. So pH3 is it undergoes to the reduction. pH3 it undergoes to the reduction and P4 to H2PO2 is it undergoes to the oxidation. So after finding of the oxidation number, I'm writing as a half reaction here. Reduction half reaction. First of all, I'm taking as a reduction half reaction. What is the reduction half reaction is there? P4 is converted into the PH3. Okay, let us see. Sir, basic medium. What are the rules for the basic medium means? First of all, okay, here also, other than oxygen and hydrogen, what are the other elements are there that we have to balance? Other than oxygen and hydrogen, what are the other elements are there that we have to balance? Okay, what are the other elements are there?
Phosphorus.
Phosphorus. So left hand side we have a 4 phosphorus, but right hand side we have only 1 phosphorus. How we can convert the 4 into 1? 1 into 4 by multiplying with 4 only na. So if you multiply with 4, so you'll get the answer. Now number of phosphorus atoms are balanced. Second condition, number of oxygens. Is any oxygens are there both sides?
No, sir.
So we need not to balance. And number of hydrogens are there? Is there na? Right hand side total how many hydrogens are there?
12.
12 are there. Left hand side how many hydrogens are there?
0.
0. How we can balance the number of hydrogens means, that is only I'm telling that wherever the excess of hydrogens are there, that side that many number of OH minus ions we have to add. For example, now you told that sir at right hand side total we have a 12 hydrogen, 4 pH3. How many hydrogens are there? 12 are there. 4 3s are 12. That means you have to add as a 12 OH minus. And opposite side, equal number of how many OH ions you added, that many number of water molecules you have to add. Now 12 H2O. Now 12 H2O. Now once you checked out number of oxygens, number of hydrogens, everything is balanced or not? Is balanced or not?
Yes, sir.
Is balanced na Samhita? Sriyuta
The
equation.
charge is not balanced.
Charges is not balanced. How we can balance the charges? Here 0 to -3. 0 to -3 means each phosphorus difference is 3 electrons are there. Like the total, how many phosphorus atoms are there?
4.
4 3s are
12.
12 electrons it is gaining. How many electrons it is gaining? 12 electrons. So P4 plus 12 H2O plus 12 electrons gives rise to 4 pH3 plus 12 OH minus. Now charge also it is balanced na. Another equation it is there. What is the another equation means here? Oxidation half reaction. Sir, what is the oxidation half reaction means? P4 is converted into here H2 PO2 minus. First of all, number of phosphorus atoms we can balance by multiplying with 4. Both side number of phosphorus atoms are same. Then what about the number of oxygens? Is number of oxygens are balanced? Here 6 oxygens are there. Okay, sorry, 2 oxygen, 2 4 2s are 8 oxygens are there. How many oxygens are there? 8 oxygens are there. Okay, so in this case, let us see, and 8 oxygens and 8 hydrogens are there. 8 oxygens and 8 hydrogens means directly in opposite direction we can add as a 8 OH minus na. If you add 8 OH minus means it is converted into 4 moles of H2 PO2 minus only na. Once you check it out, either it is balanced or not.
Yes, sir, they're balanced.
Charged charge is balanced or not? Once you check it out, charge balance. How much charge difference it is there? Total number of electron difference in a whole reaction. Samhita or Sriyuta. Javine. The total number of electrons difference in a given reaction. In oxidation half reaction. Simple logic First you can find out the difference. Here 0 to +1. For each phosphorus 1 electron difference it is there. Total how many phosphorus atoms are there? 4 passed. That means the total number of electron difference is equal to 4. It is losing. Losing of electrons can be represented at which direction here? Right hand side only, na? Hence 4 electrons. Okay, so hence here 4 electrons. That we can write as here 4 electrons. Okay, now so once we check it out, so charge balance are there. So both we have to balance means total number of electrons we have to balance now. So total number of electrons balance means second equation if you multiply with 3 means whole equation you can multiply with 3 that means how we can write here 3 moles of P4 plus 8 3s are 24 OH minus gives rise to 12 H2 PO2 minus plus 12 electrons. So this is the whole equation. Is anything is going to be cancelled? This side 12 electrons, this side 12 electrons are there. Is other than that, is anything is going to be cancelled? 12 OH minus, here 24 it is there. If you subtract the 12 OH minus from the 24 means remaining will be 2 OH minus only now. Okay. And is any other it is there? No more. So then totally you can write. So total number of phosphorus atoms here 4, 3 plus 1, 4. That 4 moles of the P4 plus 12 OH minus plus 12 H2O gives rise to 4 moles of PH3 plus 12 moles of H2PO2 minus. This is the balancing of equation. This is the basic medium. And this is one of the previous year question. This is one of the previous year question. Okay, so now you understood?
Yes, sir.
Okay, so based on this one, today I'm going to give the test for you. Okay, yeah. And what is another important concept we are having means here? We have a types of redox reactions. Based on types of redox reactions, also they ask the questions in the JEE level exam. Okay, so types of redox reactions. Types of redox reactions. So what are the types of the redox reactions, ma? Do you have any idea about that one? We have a different types of the redox reactions are there. We have a different types of the redox reactions. So what are the different types of the redox reactions we are having means? Let's check it out. First one is combination redox reaction. Combination redox reaction. Redox reaction. Combination redox reaction. Sir, what is meant by the combination redox reaction? What is meant the combination means here? When two different elements are combining together to form as a product is called as a combination redox reaction. Okay, so they have to combine and they have to form as a new product. That new product, it has to be redox reaction. Okay, that new product has to be redox reaction. Sir, what is the best example for that one means here? Simple example I'll tell my here. So what is a simple example means? Let us see. We are taking as a carbon. Carbon can be exist in a solid form and it is reacts with oxygen. Oxygen also it is the gas. Oxygen can be exist in an elemental formation. Okay, it is exist in a O2 formation. When the carbon is reacts with oxygen, it forms as a carbon dioxide. It forms as a carbon dioxide. Sir, what is the oxidation number of the carbon in carbon dioxide gas means here? +4. What is the oxidation number of the oxygen means? -2. It is -2. And elemental form, carbon oxidation number is 0. Here also oxygen oxidation number is equal to 0. But if you check it out here, 0 to +4, oxidation number is increases or decreases? 0 to +4,
Increases.
oxidation. Increasing of oxidation number is called as a oxidation reaction. Increasing of oxidation number is called as a oxidation reaction. Okay, from O2 to O2 minus. So that means 0 to -2. 0 to -2 means oxidation number is decreases only now.
Yes, sir.
Decreasing of oxidation number is called as a reduction reaction. Decreasing of our oxidation number is called as a reduction reaction. Okay, so decreasing of oxidation number is called as a reduction reaction. Now, the given whole reaction is combination redox reaction or not?
Yes, sir.
Both reactant, it has to be combined and it has to form as a product. So after formation of the product, whole reaction is it undergoes to the redox reaction or not, that we have to check it out. That kind of reactions are we can call as a combination redox reactions. You got it? Second one. So what is the another one means here? Decomposition reaction. Decomposition redox reaction. Sir, what is mean by the decomposition redox reaction? Okay, so what is mean by the decomposition redox reaction means? So one reactant is it undergoes to the decomposition reaction to form more than one product is called as a decomposition reaction. Okay, the reactant is it undergoes to the decomposition to form more than one product is called as a decomposition reaction. Sir, what is the best example for this one means here? KClO3. Okay, KClO3. If you take 2 moles of the KClO3, it forms 2 moles of the KCl plus 3 moles of the oxygen gas is going to be formed. Okay, actually it is the solid. It is heated at high temperature. It is heated at high temperature. If it is heated at high temperature means it undergoes the decomposition reaction to form as a 2 moles of the KCl plus 3 moles of the oxygen gas. Got it? Sir, how we can know either it is a redox reaction or not means here based on the oxidation number. Once you check it out, what is the oxidation number of the chlorine in KClO3? Here is -1, here is 0, elemental form it is the 0. In this case, it exhibits as a -2. Potassium, it exhibits as a plus. Then what about the oxidation number of the Cl? What is the oxidation number of the Cl in KClO3? Zavine, what is the oxidation number of the Cl? Something.
Sir, +1.
It's not -2, Javine. It's not -2. And somebody is telling +1 ma. It is not the +1 ma. Let us see. We can use the formula here. So because of +1 x -2 into 6 ma, -2 into 3 is equal to 0. -2 into 3 is equal to 0 means how we can write +1 x -6 is equal to 0. If we simplify that one means you will get as a -5 is equal to 0. If -5 come this side means how much will get as a x is equal to +5. So what is the oxidation number of the chlorine in KClO3 is means here +5. From +5 to -1 is going to be decreases. +5 to -1 is going to be decreases. Okay, oxidation number is decreases or increases? Decreasing of oxidation number is called as
Reduction.
reduction ma. O2 -1 should check it out. Oxygen -2 to 0. Oxidation number is increases or decreases?
Increases.
Increases. So increasing of oxidation number is called as oxidation reaction. Hence the given reaction is example of the decomposition reaction. Now we got here and one more question here. So what is another question means here? So it is previous year question. Decomposition of calcium carbonate is example of redox reaction or not? Decomposition of calcium carbonate is the example of redox reaction or not? Whether the given equation is redox reaction or not? It is also decomposition reaction only. So calcium carbonate is heated at high temperature. It decomposes into calcium oxide plus carbon dioxide gas. The given example is redox reaction or not, ma? It is not the redox reaction, ma. Sir, how you are telling
Sir,
that redox? Yeah, Sriyuta.
I'm only getting that oxygen is getting oxidized.
No, ma. Ma. In calcium carbonate, carbon is having +4 oxidation number, calcium is +2 oxidation number, oxygen is -2 oxidation number. In calcium oxide, it is +2 -2. In carbon dioxide, +4 -2. Is any oxidation numbers are difference it is there? Is
No,
any
sir.
difference it is there in the oxidation numbers? There is no difference in the oxidation number. If there is no difference in the oxidation number, it means the given reaction is not the example of decomposition redox reaction. It is the previous year question, previous JEE question. They had given 4 reactions. So which of the following is not decomposition redox reaction? Or which of the following is not the redox reaction? That is the question they asked actually. Okay, which of the following is not the redox reaction means here calcium carbonate is not the example of the redox reaction because of it does not undergoes the oxidation and reduction reaction. Simply it undergoes the decomposition reaction. You understood?
Yes, sir.
Understood? All of you? Okay, and one more mark here. So what is another one means here? Decomposition and displacement reactions already we know. Displacement reactions. So what is meant by the displacement reactions? I think so everyone knows. Simple example right here. Again, we have 2 types of the displacement reaction. Sorry, 3 types. Metal displacement reactions and non-metal displacement reactions. Okay, and double displacement reactions are there. Okay, already knows here. For the metal displacement reaction is best example is when the aqueous solution of the copper sulfate is placed in a zinc vessel, it forms zinc sulfate plus copper metal. In this one 0, here it is the +2, here 0. So based on the changing of the oxidation numbers, we can find out whether the given reaction is redox reaction or not. This one is example of the metal displacement reaction. Metal displacement reaction. Sir, how you are telling that metal displacement reaction means aqueous solution of the copper sulfate is it appears in blue color. Which color it will be there, ma? Blue color. Aqueous solution of the copper sulfate is it appears in a blue color. Whenever you're going to place in a zinc vessel, after some time, it gives us a colorless solution. It gives us here colorless solution. So whenever it gives us a colorless solution, that colorless solution is containing zinc sulfate. Okay. Now in this one, what happened? Copper metal is displaced as the zinc metal. Okay. Copper metal is displaced by zinc metal. Now you got the clarity. And one more reaction also studied in 10th standard. So when the zinc granules are placed in HCl or H2SO4, it forms as a zinc chloride and zinc sulfate, and they releases as a hydrogen gas. So this is also example of the non-metal displacement reaction. Okay, last 2 reactions are there. That is I'm going to be explaining here. One is disproportion reaction. Disproportion reaction. Sir, what is mean by the disproportion reaction? Any one of you? For this one already now only we had seen some example. That means P4. P4 is converted into PH3 plus H2PO2 minus. Okay, this is one of the best example for the disproportion reaction. Sir, what is meant by the disproportion reaction means here? Only one element It undergoes both the oxidation reaction as well as reduction reaction, means is called as a disproportion reaction. What is mean by the disproportion reaction, ma? In a chemical reaction, only one element, it undergoes both the oxidation reaction as well as reduction reaction is called as a disproportion reaction. Got it? Understood?
Yes, sir.
Samhita, Sriyuta, Zavine. All of you understood now? Last one, ma. Calm proportion reaction. Exactly opposite. Calm proportion reaction. Calm proportion reaction. Okay. Calm proportion reaction. So what is meant by the calm proportion reaction means it is exactly opposite to the disproportion reaction. It is exactly opposite to disproportion reaction. Disproportion reaction. It is exactly opposite to disproportion reaction. Okay. So why it is exactly opposite to disproportion reaction means here what happened? Two different elements. Here phosphorus is exhibiting the two different oxidation numbers. Similarly, the atom of same element it exhibits as two different oxidation numbers. For example, silver is there. Silver it exhibits as a +2 oxidation number, and one more silver atom. If these two are combining together, means it forms as a 2 moles of the Ag+. Here silver is 0 oxidation number. Now once you check it out, one element starting. So the atom which exhibits two different oxidation numbers combining together, it exhibits as a single oxidation number is called as a calm proportionation reaction. Is that clear? So this is about the types of reactions and balancing of equation. So based on that one, today I'm not going to give any test, but I'm forwarding some assignment. Previous year questions I'm going to be forward to you. You have to practice all that questions. Okay?
Okay, sir.
That is your homework. Okay? Then we'll continue. Redox reaction also it is finished. Only one concept is that tomorrow I'm going to be finished. Okay?
Yes, sir.
Okay, sir.
Right, ma. We'll continue in tomorrow class. Thank you all.
Thank you, sir.